In last session we have seen how to do meshing, and in this session we are going to see how to provide loads and boundary conditions. So to provide a loads and boundary condition, we'll click on static structural and context menu will change to the environment. In static structural we can apply inertial loads, some line pressure loads, remote force, some supports like simply supported loads, fixed rotation, fixed support, displacement, and some other loads which we are not going to discuss in this course. Let's apply the boundary condition and loads. Before that, let's look at the problem statement, what it says and what is condition and what are the loads. The problem statement says that the first node is a fixed node, the second node is applied the compression load of 15,000 Newton. The third node we have applied the load of 35,000 Newton, and the last node is subjected to pull load of 15,000 Newtons. Let's go back to the mechanical and apply the loads. To apply a load, we'll go to the toolbar and we'll select a vertex filter. We'll select the first vertex and we can apply the fixed support from here, or by right clicking on a static structural, insert fixed support. So the first node is a fixed support. Now we'll select a second node or a vertex and we'll say right click and insert force. So in a force detail, geometry selected this one vertex, and defined by we have option of by vector or by components. Our recommended is components. So we'll click on a components, can give a x, y, z component. Just look at in the z direction to see in a front view. We want to apply a load in a x direction. We'll click on x component and we'll type minus 15,000. Minus indicates its compression load, and that is negative x direction. We'll say enter. So this first load on the second node is applied of minus 15,000 Newton. Now we'll click on the third node, and on third node we have to apply the load of plus 35,000. So we'll go define by components and x component 35,000. So second node is applied the force, third node we apply. Now at the last node we have to apply the force of, you can apply force from here or from here. Force defined by components and 15,000 positive. So we apply all the three loads. To verify, we'll click on static structural. It will give you all full picture. So this D fixed support, this A compressive load of 15,000 Newton, B pull load of 35,000 Newton, and C a pull load of 15,000 Newton. So that's as per our problem statement. If you want to visualize the cross section, you can anytime go to the display and we'll click on cross section, so you can see in the 3D cross section view. But this is just a representation, as you already know that we have done midline extraction. The next step is solving a finite element model. To solve a finite element model, you can right click on solve here, or you can go to the home and you can press this solve button. So it's solving now. We can see the status bar, building mathematical model and solving mathematical model. So it builds the model, you remember, which we have discussed in the past session. So it solves this equations. It builds for every element and then integrate it and gives you the primary variable. Primary variable is u in our case. So let's see primary variable first by right clicking on solution, insert, and deformation, total deformation. We'll say right click and evaluate those results. So your result is evaluated and deformation is 0.25607 mm in this case. We'll discuss a post-processing kind of things in the next video in detail to view the stresses, forces, and other items. That's all in this session.